So they didn't wait for permission. They didn't ask to be invited into the AI revolution. They built their way in. Welcome to the Spotlight series with Gen Zs, the show where we stop talking about the next generation and start talking to them. And I will say this is with full pride. As an engineer myself, there is something incredibly special about introducing two extraordinary girls from the engineering community because I know firsthand what it takes to get there. Here's a stat that should wake everybody or every corporate leader up. The generation that grew up Googling answers before they could drive is now building the AI, which will drive your business decisions. And Gen Zs and AI are not, incompatible, just compatible. They are just inseparable. And today, I want to show you exactly why Gen Zs are not just adapting to AI, but AI is adapting to them. So my guests today are the two Gen Z engineers who just walked out of their university gates and into the tech industry now. And before they even collected their degrees, they had already built something extraordinary and your real-time AI-powered low-light enhancement system. This is not a theory, but a working solutions to the problem that surveillance systems and autonomous vehicles and medical imaging industries deal with every single day. Before we dive into the show, let's meet the builders. Sanjana and Raveena, welcome to the spotlight. Let's build something with this conversation. Please introduce yourself. Raveena, why don't you kickstart?
Thank you so much, Rajesh sir. It's genuinely an honor and thrilled to be here. I'm L. Sai Raveena Sowgandhika. I just completed my BE in Computer Science and Engineering at Sathyabama Institute of Science and Technology, Chennai. And I'm proud to share that I have already secured a placement, so the corporate chapter officially begins soon.
Wow, fantastic. Huge congratulations on that, Ravina. And I know you mentioned Satyabama is, I think it's widely known for its strong industry connect and placements and real world tech exposures. And I must say, I have also heard legendary things about your campus canteen.
Yes, sir, yes. The food is genuinely great, but more importantly, as a student, the campus felt incredibly safe, inclusive, and supportive, especially for women in tech and students coming in from other states. The environment shaped us more than we realize.
Oh, good. So you from Andhra. Okay, great. That's a
Yeah.
beautiful testimony for your college. And I'm certain your management and your professors and founders will be incredibly proud seeing you in this show representing the institution here. Thank you. And Sanjana, over to you.
Yeah. Hi, Rajesh sir, and hello everyone watching. I am Sanjana, like Raveena. I just completed my engineering degree in CSE at Sathyabama. 4 years of core computer science, advanced mathematics, data structure, algorithms, and of course, a deep dive into artificial intelligence. Right now, I'm finalizing my transition into the industry through campus placement at a leading software firm in Chennai.
Brilliant. Congratulations to you as well, Sanjana. And now here is a question I love asking anybody, right? Especially you guys are coming out of the campus. Uh, Out of everything you studied across the 4 years degree, engineering degree, which two subjects completely stole your heart?
Yes, so for
Ravina?
me, my favorite subjects are DBMS and software engineering. So I have always been curious about how applications manage huge amount of data behind the scenes, and DBMS gave me that understanding. Software engineering helped me learn how software products are planned, developed, tested, and maintained efficiently. Since every successful application relies on both strong data management and as well as well structured software development practices, so these subjects naturally became my favorites.
So you like the
Yeah.
DBMS and software engineering. Okay, sorry. Over
Yes.
to you, Sanjana. Go ahead.
Yes, sir. I completely second that. But for me, mathematics and compiler design always stood out. Mathematics taught me how to approach problems logically, and compiler design revealed the magic happening behind every line of code we write. When I learned how a compiler converts human readable code into machine instruction, it completely changed the way I looked at software development. That's when computer science stopped feeling like just a subject and started feeling like a powerful way to solve real world problems.
Wow. And that brings us perfectly to why you are here, right? So your project is awesome, and thank you so much. And I want to say this in full because it deserves to be said about your project, right? Which we are going to be discussing now. So, Edge-Aware Unified Retinex Architecture for adaptive low-light enhancement of images and videos across diverse domains in real time. I think this is your project paper, right?
Yes,
Yes,
sir.
sir.
Okay, okay, great. So, unto audience, this is not just a title, this is a statement. So we have these two girls break it down for us, and let's listen to them. What is actually you are solving here through this project, Ravina?
Yes, at its core, we built a real-time system that takes severely dark, low-light images or videos and instantly transforms them. It dramatically improves visibility, brightness, contrast, and color consistency. But here is where it's get interesting part is like it does all of that without blurring edges, without introducing noise, and without requiring powerful servers, all at real-time speeds.
Mm-hmm. Mm-hmm. Great. But in a layman, right? Let me throw a real world curveball at you. Because I know the LinkedIn reviewers or the people who are going to watch this video already may be thinking this. Can your system enhance the old personal photographs, that were faded and dark and grainy, taken 40, 50 years old?
Yes, sir, absolutely. While our core use case targets real time video, that architecture is robust enough to handle static vintage photographs too. It
Mhm.
maps dark regions, recovers hidden textures, corrects color fading, and stripes out aged film grain. So it could genuinely bring old family memories back to life, and that's a beautiful application we hadn't originally planned for.
Oh, good. So bringing old family memories back to life. I love that.
Yeah.
Great. So I will send you a bunch of my old photographs to you, and probably you guys can use your systems and technology to convert that into a bright best one. Thank you. I love that.
Sure,
And
sir.
yeah, unintended impact is often the most powerful kind, right? That's the saying. And now let's talk about the problem landscape, right? What's broken about the existing low light enhancement technology today?
Yes, sir. The three fundamental flaws dominate the current market. Firstly, they are computational monsters. They need massive GPUs and are simple, too heavy for real time edge deployment. Secondly, they create visual inconsistencies. Over enhancement introduces unnatural color distortion, blown out highlights, and glowing artifacts that actually reduces the image usefully. Thirdly, and this is the killer problem for videos, temporal inconsistency. When frame by frame enhancement lack continuity, the video flickers violently. You are essentially making a surveillance feed unwatchable.
Great, awesome, Sanjana. So you are saying like you set out to solve all these three problems simultaneously. Fantastic. Can you walk me through exactly how your pipeline works step by step?
Yes, sir. We built a hybrid pipeline, like classical image processing combined to a lightweight deep learning model. So let's start with step one. So input and pre-processing. The system accepts live video streams or static images and standardizes them. And will step two is illumination correction. We pass data through multi-scale Retinex to fix uneven patchy lighting. And then color restoration. We apply MSRCR to immediately bring back natural true colors. And then step four, adaptive refinement. So a deep learning network called Zero-DCE++ then fine tunes contrast without blowing out any pixels. And then noise suppression. An Edge-Aware filter removes the noise introduced during the enhancement process while preserving important image details. And then we'll move to temporal consistency module. For video, this module is the backbone, like it locks frame to frame stability so the output is smooth, not flickering. So and then the last step is like output evaluation. Finally we compute PSNR and SSIM matrices to prove quality improvement. So these are the steps, sir.
Okay, so there seems to be a lot of steps and a lot of
Yeah.
technologies and jargons, but to make things life easy, but excellent engineering. So, but I will try to sum up just tell me whether it's right. So the step one is input and processing, pre-processing. Step
Yes, sir.
two is illumination correction. Step three is color restoration. Step four is
Yes,
adaptive refinement. Step
yes,
five is noise suppression. Step six is temporal consistency module, and step seven is output evaluation.
yes, sir.
Yes.
Fantastic. Let's unpack the pre-processing layer first, right? Which is, I
Yes.
think, the first step, right? So what happens before the AI even takes over this step?
Actually, pre-processing is the unsung hero of every pipeline. The module reads raw inputs, extracts individual frames for videos, resizes everything to standardize operational dimensions, and normalizes pixel values to a uniform 0 to 1 scale. You are essentially giving the deep learning blockchain consistent, digestible data, which is the difference between a module that performs and that one guesses.
Wow, fantastic. So you summarize the pre-processing very well. Let's move on to this next step. The two acronyms I saw that central round to your paper. One is MSR and other one is MSRCR. I seems to be like these are similar sounding, but fundamentally different, right? So can you help me to understand that?
Yes, sir, that's a great question. This is where our approach truly stands out. MSR is multi-scale Retinex. It exceptional at pulling hidden details out of deep shadows and correcting uneven illumination across the images. But on its own, it can leave images looking washed out or tonally flat or almost gray. When coming to MSRCR, it's a multi-scale Retinex with color restoration. It uses a dynamic color restoration function to rebalance the channels, essentially re-injecting the natural color the screen actually had without artificial saturation or color shifts.
Love it. Fantastic. So that's about the color restorations and the technology behind it. Now coming to the step four, which is adaptive refinement. Uh, what is this architecture available to you, and why did you use this zero DC plus plus?
Yes, sir. Zero DC plus plus was one of the only choice once we understood what we needed. Here is why it's game changer. Means it's incredibly lightweight, which means it runs fast, essential for edge deployment. It's a zero reference network. It doesn't need paid ground truth images for training. It frames light enhancement as a curve estimation problem, like dynamically adjusting brightness at a pixel level without overexposing. So it's exactly what real time systems need.
Fantastic. Great,
Yes.
Ravina. Thank you. So we spoke lot about technologies and tools. Right now, let's for the tech people, right? The leaders listening to this podcast and the conversation. Can you guys, give us the full development stack of, what technologies did you guys use as part of your paper?
Sure, sir, sure. It's entirely open source and production ready. So we used Python as a primary language and OpenCV plus NumPy used for core pixel and matrix operations, and TensorFlow and PyTorch for training and executing the deep learning curve estimators, and then Matplotlib for output visualization and metric evaluation. So our main core principle is of the project like lean, powerful, and deployable.
Fantastic. Lean, powerful, deployable. I love that, the lines. Great. So now this is where it's getting exciting, right? Because
Yes.
this is not just an academic exercise, right? The commercial value here is enormous. I just tried to do some research yesterday. Where does this architecture live in the real world?
Yes, sir. Across multiple multi-billionaire dollar sectors, CCTV and surveillances were real-time nighttime enhancement of security feed, making faces and plates identifiable in completely darkness. Autonomous vehicles helping self-driving systems accurately detect pedestrians and obstacles in pitch black or foggy conditions. Medical imaging enhancing low visibility endoscopic or diagnostic scans where detail is literally the difference between a diagnosis and a miss. Coming next thing is mobile photography, powering next generation night mode direct inside smartphone cameras on device in real time.
Wow, that's great. I mean, that seems to be a huge industry. As you rightly said, it's like a multi-billion dollar sector. I mean, you mentioned CCTV, which is about safety and security. Autonomous vehicle is like car without the driver, and the transport industry, and medical imaging is part of the healthcare, which is very, very important. And mobile photography, I think everything is mobile today, right? People hardly uses
Yes, sir.
laptops other than people working in office. But excellent. Quick layman question one more time: can this drop directly into the existing smart CCTV infrastructure today?
Absolutely, sir, because it's lightweight and runs at 30 frames per second without needing centralized server infrastructure.
Mhm.
It can be deployed directly on edge devices co-located with the camera. No cloud round tips, no latency, just immediate real-time enhancement right at the source.
Wow. And this is what I think practical AI engineering looks like, right? Fantastic, guys. Thank you. This is awesome. Now, we wrap every spotlight episode one the same way. So, rapid fire questions, right? I will ask you 5 questions, each one of you. You have to
Yes, sir.
just answer in 3 words or less. No overthinking. Okay. Don't
Yes, sir.
think too much.
Yes, sir. Yes, sir.
So, let's jump in. Ravina, your 5 rapid fire questions. So, the
Yes,
first
sir.
one,
Sure.
uh, you are a software engineer, a programmer.
Mm.
So,
Yes.
what is the coding fuel of choice? So, you mean like coffee, chai, or energy drink?
Coffee always, sir.
You are a coffee person. Great.
Yeah.
And second question, favorite spot on Sathyabama campus to decompress?
The college canteen.
So, you are a foodie person. Good. Okay.
Yes, sir.
Third one, one word for you, your project guide. Uh, who's he?
Yuvan Felix, sir. Actually, he's incredibly supportive.
Wow. So, you say that's professor is incredibly supportive. Great.
Yes, sir.
Python or C++ for your computer vision?
Python, sir, every time.
Hmm. And your biggest career dream in AI?
Leading AI innovation.
Wow, that was really quick. Thank you, Ravina. Let's move on to Sanjana. Now it's your turn. Uh, toughest bug you fixed in this entire project?
Video frame flickering, sir.
Hmm. And you like to debug at 2 a.m. or 6 a.m.?
Always and definitely at 2 a.m.
Oh, you're a midnight person. Okay. Okay, good, good. Chat GPT or Stack Overflow when you try to code the breaks?
Chat GPT for speed, sir.
Okay. One non-technical skill that you feel every engineering student must develop?
Clear communication, sir.
Okay, non-technical skill, you say clear communication is important. Fantastic. I 200% agree to that. Yeah, communication is everything.
Yes, sir.
Last question. Complete this. AI will not replace humans. It will dash dash
It
dash
will
dash.
empower our potential.
Oh,
Mm.
empower your potential. Fantastic. Perfectly handled. You guys, perfectly handled the pressure test, and both of you stayed calm, sharp, and quick. And that's the Gen Z energy right there, right? So good, guys. So before we close, I want to give you both a genuine moment to acknowledge the people who made this, the projects and papers possible. So 2 minutes to go.
Yes, thank you, Rajesh sir. Our deepest gratitude goes to our project guide, Dr. A. Yuvan Felix, Associate Professor, CSC Department at Sathyabama. His technical insight, patience, and his mentorship carried us through every roadblock. So, a project guide like him is a rare privilege for us.
Yes, sir. We also want to sincerely thank our college management, our department heads for building an ecosystem where students like us can actually build, experiment, and fail forward. To every professor who laid our foundation, thank you. And to our parents, your sacrifice, your belief, your late night check ins, asking if you have eaten or not, that unconditional support was the fuel behind every line of code we wrote.
Wow.
And Rajesh sir, a personal thank you to
Thank
you.
you.
This platform where an industry leader takes real time to amplify the work of fresh graduates is very rare, sir. It's genuinely empowering. You didn't just give us a stage; you told us our work matters. That means more than we can express, sir. Thank you.
Thank you so
Whoa.
much, sir.
Thank you, guys. I mean, it's my pleasure, and the privilege is entirely mine, and I mean it wholeheartedly. And here's what I want every leader, every hiring managers, every senior managers watching this to take away. Gen Z is not the future of AI; they are the present. Sanjana and Ravina built an production-grade AI system before their career even formally began, not because someone gave them the resources, but they had the passion, rigor, and the refusal to wait for permissions. And if you are a Gen Z viewer watching this right now, this is your signal. Build, publish, and present. Put your work in front of the world, and the stage is yours. Ravina, Sanjana, thank you for bringing the heat today. Go and build the world you want to live in. We all will be watching you. And that's a wrap on today's topic. Stay curious, stay building, and stay tuned for the next spotlight. See you in the next one. Thank you.